science talk conducted by the Department of Chemistry, University of Columbia. My name is Chamka Gunatilaka, who is a final year chemistry special student. Today I will be interviewing Professor Christopher Cramer, who is currently a distinguished Knight and teaching professor of chemistry, chemical physics and scientific computation at the University of Minnesota. He holds the post of the Vice President for Research at the University of Minnesota. In addition to his academic duties, he also served for 15 years as editor-in-chief of the scholarly journal Theoretical Chemistry Account and for 20 years as an associate editor for the Journal of Physical Organic Chemistry. He has been recognized as a fellow by the American Chemical Society as well as by the Alfred P. Sloan and John Simon Guggenheim Foundation. Professor Cramer is a recipient of the Arthur S. Fleming Award, and he is also the author of the textbook Essentials of Computational Chemistry, Theories and Models, and of over 450 original research articles, and his work has received about 46,000 citations. Good morning, Professor. Thank you for allocating a valuable time out of the hectic schedule to take part in this interview. To begin with, Professor, would you please explain how you spent your childhood and some details about your early education?
Sure. First, let me thank you for the invitation, and I'm looking forward to the conversation. So I'm flattered to have been regarded as sufficiently eminent to interview. I think my childhood is probably unremarkable. I grew up in the Midwest of the United States, so I was born in Illinois, which is the state where Chicago is. At a relatively young age, I moved to Wisconsin and lived in various cities in Wisconsin as my father moved from place to place for his work. I took public schooling throughout that period, and as I grew older and began to focus a bit more on interests, I would say mathematics was really terrifically interesting to me. I always was fascinated by math and math puzzles and logic puzzles. And then I also did a fair amount with foreign languages. I studied French and German while I was in high school. And then later in high school, chemistry was a class I enjoyed. I can't say it was my primary interest. I really was focused on math. I ended up going to college, starting as a major in mathematics, and became more interested in chemistry actually while I was in college. But that's about it. Yeah, sort of a standard K through 12 progression in the United States prior to going to college.
Professor, what were the things that inspired you to choose chemistry as a major field?
So as I said, I went as a as a math major, and nevertheless, I had to take certain science courses. That's required to do that, and I did have some interest in chemistry, and I ended up testing out of sort of beginning chemistry, and I took an organic chemistry course fairly early on. And you know, it's one of those classic stories that I just had this professor for organic chemistry that I simply adored. I thought he was wonderful. His name was C. David Gucci, organic chemist, and I ended up actually asking if I could be an undergraduate researcher in his lab, and he let me do that. And shortly thereafter, I declared a double major. So I majored in both chemistry and in mathematics. The chemistry department thought it was crazy that I was an organic chemist who was a major in mathematics. They thought physical chemists should do that. But anyway, it was a good combination. And it was, you know, it had been my intent when I went to college also to ultimately go to medical school. I thought I would be an MD. And in fact, in my senior year, I applied to both medical schools and to chemistry graduate schools. And it wasn't until sort of the very last moment that I decided I would take one of the offers from a graduate school as opposed to a medical school and pursue a PhD.
Professor, in your opinion, what type of role does chemistry play in the modern world, and how has it connected to our day-to-day work?
You know, when you say it's the central science, I guess you have to define a metric, because central implies that you are somewhere on a scale. And I think there are valid arguments to be made that if you think about length scale, chemistry is relatively central. We don't do subatomic and we don't do galactic, but we do a lot of length scales in between, from bonds and molecules up to materials of macroscopic size. You can also talk about time scales. And if you think about time scales in chemistry, we go from pretty darn fast, sub-femtosecond, although not down to, little physics, sub-attosecond things, up to, days, weeks for those chemical reactions that you hate to wait for, but not quite geologic timescales, astrophysical timescales. So we're central that way. And then I guess I'd say finally, people interact with things, matter and energy as well. And chemistry is really concerned with how do you make the things that people need? How do you remediate the wastes that are created by civilization? How do you create enough energy to sustain civilization and do so in a sustainable way? I think chemistry plays a particularly key role in a modern technological society.
So my next question is, Professor, you began your graduate education in synthetic organic chemistry, but after 2 years, you changed your research area to molecular modeling. What was the reason for changing your graduate education pathway into a new area after 2 years?
Yeah, there's sort of three answers to that question. One is the mathematics got me again after having sort of put it down for a little while I was doing synthetic organic chemistry. The second one is the chemical literature, I suppose. As I read widely, as all graduate students should, I came across a lot of work that was being done in modeling by, real titans of the field, like Ken Houck at UCLA, who just won the Roger Adams Award here in the United States. And he was, using modeling to gain mechanistic insight, where I was trying to interpret from products of chemical reactions what mechanisms were. And I really appreciated the degree to which modeling could almost be like a microscope into the process of how bonds were being made and broken. So that really excited me, the potential of molecular modeling. And then the third reason, which plays a role too, is I'm not sure if you've ever done flash chromatography. So it's an analytical technique whereby you separate an impure compound and try to make it pure. And I have to tell you, it is fabulously boring. And after you've done your 7,000th flash chromatography to purify a compound, boy, working with a computer starts to look really good. So I have always been excited by what I could get done with my digital technology, and got bored, frankly, with some of the routine things that had to happen in the research laboratory. In fairness, if you progress far enough, of course, you ultimately have technicians who take care of that sort of thing, and technology itself has gotten better, but it pushed me a bit in that direction.
Professor, before joining the University of Minnesota, your professional career began with 4.5 years of service as an active duty officer in the United States Army. What inspired you to enroll in the United States Army, and after that changing your career into a completely different area?
So as you probably know, in the United States, higher education is not free. One has to pay tuition, and depending on what school you go to, it can be quite expensive. I actually attended an undergraduate school called Washington University in St. Louis. It's a private school. And at the time, it was in the moderately to fairly expensive category. And my parents were not particularly wealthy, and I didn't want them to have to pay for my college. The military in the United States has a program called the Reserve Officers Training Corps, ROTC. And essentially, if you sign up and say that you will pay back 4 years of your life as an active duty military officer, then you have the opportunity, it's not guaranteed, but you can compete for a scholarship that pays all the costs of your college. And so I actually did win such a scholarship. So they paid for my college, and that meant that once I had my degree, I had to give them back some time. They did let me finish a PhD first, so that was not paid for by them because you get paid to do research as a graduate student. But they just, let me suspend my service until I finished my PhD. So after the PhD, I began as an officer in the Army. I spent about 4.5 years. I left as a captain. It had never really been my intent to pursue a career in the military. I just wanted to give back the time that I owed. I did get tempted at the very end because they suggested I could maybe go up in the space shuttle as a mission scientist. But ultimately, I decided I would rather go back to academia and try my hand as a professor.
In the modern scientific research, collaboration is important for ensuring research quality. Institutional quality is also improved by collaborations. The partnership among researchers ensure that their knowledge, skills, and techniques are made available to everyone interested and mutually benefit the participants. The more researchers collaborate, the greater are the chances for success and problem solving. Professor, you and Professor Crowler's collaboration has led to many excellent findings. What is your opinion regarding the collaboration?
It's a interesting question. I think if you go back historically, sort of a long way in science, there has been a tendency for there to be a celebration of individuals, right? You think about the great contributions of individual X, individual Y. And increasingly, as science has become more complex and technology more complex, to make progress on some of those problems, you really need to bring talents from more than a single individual. And so collaboration becomes terrifically important. I'm slightly famous here at Minnesota, at least in the chemistry department, for having published papers with more senior colleagues, other faculty members. I have 40 different colleagues I've published papers with. And that's not just in the chemistry department. There's not even that many in the chemistry department. That's also faculty in other departments at the University of Minnesota. And it's been a joy to do that because every one of those collaborations teaches me something, because I didn't know what I needed the other person to contribute, but I did learn something along the way. You mentioned my collaboration with Don Trular, and that has indeed, we don't work much together anymore, every once in a while, but for 20 odd years, we developed solvation models together that are now quite common in quantum chemical modeling. And, we were a very well-matched pair because he was a really brilliant, still is, a really brilliant chemical physicist, very adept with the mathematics, sees deeply into mathematical models. And I came in with a much more expansive knowledge of sort of chemical applications. I had synthetic experience. I sort of knew what organic chemists would care about, what inorganic chemists might care about. And as a result, as we would develop our models, we kind of mutually pushed each other in a direction such that the vector sum was the right way to go. Sometimes Don would want to go in a direction that I knew was, going to create something too complicated or failed to recognize a certain aspect of chemical space that needed to be accounted for. And then sometimes I would want to do things that were a little bit too maybe empirically corrected, and he saw a way to have a more general solution that would make the model more robust. So I agree that was a terrifically successful collaboration. I think he might be the person I've published the second most number of papers with. Well, maybe he's still the first. My wife is charging very strongly. We also collaborate. So that's a different kind of collaboration, though, once you're talking about your spouse.
Professor, you are the Vice President for Research at the University of Minnesota. Before this appointment as the Vice President, you serve as the Associate Dean for Research and Planning and Academic Affairs in the University's College of Science and Engineering, as well as at one-time Chair of the Faculty Consultative Committee. What kind of role do you play as the Vice President for Research?
Yes, so I'm here in my Vice President for Research office, actually. And what the Vice President for Research does at an institution like the University of Minnesota is really try to ensure that the infrastructure necessary for researchers to be successful is there. And when I say infrastructure at a research institution like the University of Minnesota, which spends $1 billion a year on research, that covers a staggering number of fields. So that's biomedical research, that is agricultural research, research in sustainability, engineering, the sciences, humanities, arts. It's sort of everything. It's truly a huge operation. And so that includes compliance activities. So if we work with human participants, we want to make sure that their rights and safety is protected, and we have protocols to do that. There are researchers who work with animals. We have ethical obligations to ensure that the animals are treated appropriately. There are large pieces of infrastructure that no one researcher could afford, but one uses them as a central facility, for instance, and those might be magnetic resonance instruments, electron microscopes. So we have facilities that we need to be sure are funded and that we're constantly upgrading the equipment. And then finally, there are, really big strategic projects that, some agency is interested in funding a center or an institute that may be at more than a single university, and it may involve national laboratories. So it's sort of my role to try to coordinate some of those really large projects. And to represent the university to various stakeholders and funders. So the state of Minnesota, which provides budget to the University of Minnesota, to federal agencies that give us money. It's a broad role.
Professor, this question is somewhat related to my previous question. How do you manage to fulfill these responsibilities amidst your hectic schedule?
A question I ask myself on a frequent basis. I would say, I wish I had a really good answer to that question. You just learn time management skills along the way, and that has been absolutely critical. It's been, the reason I'm pausing a little bit is thanks to the COVID-19 pandemic. This is the first time I've been in my office since March. And I didn't just come back to talk to you. In fact, I'd have been happy to talk to you from my home. It turns out we have an undersecretary of the Department of Energy visiting campus today, and I'm the person who's going to meet this dignitary in about an hour. And so working from home has made it a little easier because it turns out you don't have to spend the 15 or 20 minutes to go back and forth from home to office. And I own cats, and they're so happy to work with me all day long. But it is true that I am blessed with an executive assistant, actually, who manages my calendar. And so I pretty much go where I'm told, and I get to look and see what I'm expected. I've got a communications person who handles the things I need to say, like greeting the visitor. And so I have a fabulous staff that assists me in many of my operations as Vice President for Research.
Professor, your research interests include theoretical characterization of small molecule activation at transition metal centers, modeling catalysis to advance sustainable chemistry and chemical processes, molecular and material phenomena associated with solar energy devices, modeling remediation of environmental contaminants and chemical warfare agents, development and application of content-based content chemical models. Growing worldwide demand for energy and problems of scarcity and environmental impact associated with conventional sources are at the base of a very probable energy crisis in the next 2 or 3 decades. Professor, your recent research has been supported by the Department of Energy, the National Science Foundation, and the Defense Threat Reduction Agency. According to your vision, what type of role will solar energy play in the future world?
Yeah, so you allude to a probable energy crisis in the next 2 or 3 decades. I'd say it's here. It's here right now. Global climate change is taking off faster than some of the worst case models predicted. a lot of that's driven by fossil fuels, putting additional CO2 into the atmosphere. So we're we may be too late, although that's a somewhat disappointing view, but certainly we should be doing absolutely everything we can right now. And if you ask, how do you provide the terawatts of energy that the global consumption needs, it's pretty hard to ignore solar as the most obvious and most clean resource, because the amount of power impinging on the Earth's surface from the sun every day vastly exceeds our needs at the moment, and probably vastly exceeds any needs we could imagine for another century. There's just that much solar energy. What's hard is to capture it and store it. And obviously there's tremendous advances that are going on every day on that front, both immediate harvesting through some sort of photoelectric device maybe that converts solar photons into electricity, but also harvesting those photons and putting them into chemical energy that can then be released in some clean way. Water splitting is a popular one, where you turn water into hydrogen and oxygen, and then you burn the hydrogen later on to generate electricity, and you only make water. So it's about as clean as it gets. So I'm terrifically optimistic that we have the opportunities with solar energy to address many of the energy needs and reduce our reliance on fossil fuels. I do think that frankly, the other sources that are occasionally looked at would be nuclear power, and that includes both fission, which we have lots of around the world now, nuclear plants, as well as fusion power. I think in the fission front, there have obviously been some terrifically horrible accidents. Chernobyl is probably the worst example, but also in Japan, the meltdown of a reactor. And those are engineering challenges that need to be addressed if we're ever going to use fission successfully. I think nowadays smaller fission reactors, these little modular ones that are not the massive containment domes that pose certain kind of risks, those could be useful, but still they're nowhere close to what solar can do. And fusion seems always to be just 10 to 20 years away. I think 50 years ago it was 10 to 20 years away, and it's still about 10 to 20 years away. So boy, I hope somebody cracks that problem, but I'm not expecting it anytime soon. So I'll come back to, solar is really where we should be pouring our resources right now.
Professor, you serve as an American Chemistry Society expert on the remediation and destruction of chemical weapons. My next question is an open question. Do we need chemical weapons?
Well, that's a philosophical question, isn't it? Not really a chemist question. Do we need chemical weapons? I mean, speaking as a former Army officer, I can tell you that there's all sorts of good ways to kill somebody. You don't have to use chemistry, and we could debate the morality of any weapon, I suppose. A rifle, a hand grenade, an anti-personnel mine, a bomb, a chemical weapon, you name it. And so now I guess you have to ask philosophical questions about human societies and the national defense of sovereign nations and so forth. These are questions that are also well posed to philosophers, historians, people in the humanities. I think what I would say is, in my own experience, and certainly as a chemical officer, by the way, chemical weapons, in some sense, are terrible weapons. They're very dirty. It's not that you can employ them terribly effectively for your own strategic advantage. Once they are deployed, you've just created some area, if you will, that's contaminated. You may have eliminated a great number of enemy, but it's going to be hard for you to go in there too, because now it's a mess. And that's typically not what you'd like to do. And that's why I think we have largely seen chemical weapons have been used as weapons of terror, not as weapons of strategic advantage by traditional nation states. And so in some sense, that's more the issue, is that there are organizations willing to use chemical weapons as weapons of terror. They're not that hard to make. And as a result, we need to have an understanding of how we would go about countering such weapons, remediating their effects, being prepared to deal with them. And that's really where my own research is focused, is, how do you clean them up? How do you effectively protect against them? How could you filter against them, perhaps with a filter that decomposes them along the way? It's really more a protection and remediation strategy.
Professor, you have won many awards, including the George W. Taylor Distinguished Service Award in 2013. I know that the pathway for achieving this award was not an easy one. Professor, what kind of obstacle you have to overcome to achieve your goals?
Yeah, I read that question when you first sent it to me, and I've continued to ponder it because, I feel sort of privileged in a way that I'm not sure I've faced any unusual obstacles in my career. I have raised a family along the way. That is an obstacle that many people face as you try to juggle the time required for children, for a spouse, along with professional obligations. But it's certainly nothing I can claim uniquely. That's, again, you learn a lot of good time management skills along the way. And I've been blessed with an institution, the University of Minnesota, that has been a particularly fertile place to do research. The things I need include computational facilities, and we have some of the best. So were I at a smaller institution and it was hard to get CPU time or something, that would be an obstacle, I suppose. I've also been blessed with some, tremendous coworkers along the way, graduate students, postdoctoral researchers in my group who I have learned from and who it's been a joy to provide some mentorship and watch as they grow in their careers. I would say, the only obstacles have sort of been the typical ones, which is it takes money to do research because you're paying researchers, you're purchasing equipment and the like. And certainly in the United States in the last 2 decades or so, the amount of funding available to support scientific research, basic research, has, in some areas at best remained steady, and in others it has declined. And that has led to more competition for those resources. Competition is certainly a good thing in terms of picking the best ideas out of a collection of ideas. But at some stage, if you're down to, only 1 out of every 20 proposals, for instance, can be funded, it's not that second proposal wasn't really, really good. It's that you just are limited in resources. And, it's frustrating all the time that the people who put into those other good proposals, in some sense, it's wasted. They don't have the support, and, that's not how you'd like to run things. So I would love to see a recognition that it is important to make these kinds of investments in our scientific and technological enterprise. And that's true worldwide. I think that, governments need to make that kind of investment in order to continue propelling progress into the future.
Professor, are you satisfied with your achievements so far?
That's an interesting question. If you're totally satisfied, I guess it's time to retire. I think what I would say is, one of the chemists have a lot of different directions they can go, right? Many, many chemists go into industry, or at least in the United States, there's also a lot of national laboratories that they can work at, and it's different from academia, and I went into academia. And one of the joys about the academic path, actually, from my perspective, is if you ever get bored with something, which, could be considered to be equivalent to being satisfied with your achievements so far, right? It's no longer all that exciting. And I kind of alluded to way back in graduate school when column chromatography stopped being exciting to me. You can do something different as long as you can find the resources to support what you're interested in. My own research directions have evolved tremendously from when I began. I really was pretty focused on what might be called physical organic chemistry when I began as a faculty member. But nowadays, my remaining research group, it's quite small because I've been winding it down as vice president for research, but the people who remain with me are working on things like metal organic frameworks, which are these, macroscopic, fascinating new class of materials involving metal-containing nodes and organic linkers and very unique structures and potentially catalytic properties and photophysical properties, things I would not have had a clue how to do 20, 25 years ago. And so, that ability to constantly be intellectually changing your focus, and in my case, also to pursue administrative interests. So when I sort of became, bored is maybe too strong, but I was finding normal chemistry routine, the opportunity to do things in the dean's office in our College of Science and Engineering to now act in my role where I am today, poses new challenges. So that gives an opportunity to undertake new achievements. So I wouldn't say I'm satisfied. I'm working on some big projects as Vice President for Research, and if they all come to fruition, I'll be excited about that and hopefully satisfied. And then maybe move to something else, maybe not. I think the important thing is to keep looking for the things that engage you intellectually.
You are a singer whose taste in music spans the musical theatre, rock and singer-songwriter genre. As I think the perfect word for describing you is multitalented. But 21st century young adults have attached their boundaries. They don't have a desire to discover beyond their boundaries. All they need is to get a good job and earn money. Professor, what do you think about this trend?
Well, first, I'm very flattered to be called multi-talented. It is true, I like to sing, but I'm not quite sure I'm ready to accept your proposition that 21st century young adults are only interested in getting a good job and earning money. There's, a few billion 21st century young adults, so it's always dangerous to categorize quite that many people quite that simply. But I think what I would say is, and in fairness, I'm much older than you are, but still I'm only 59 years old now, and hence I don't have a 1,000-year of civilization timeline to claim I have experience with. Nevertheless, over my own limited 59-year timeline, the level of economic uncertainty worldwide at the moment is probably a little greater than it was 1, 2, 3 decades ago. That clearly depends on where you live. It's certainly true in the United States, but I think there are other places that globally there has been some segregation of wealth, some challenges obviously associated with global climate change. And so naturally, of course, people look to their own, security before they have an opportunity to think about sort of higher levels of challenges and things they want to address. And, perfectly understandable that young people beginning and maybe looking for their first job and their first true independence, want to secure that and do so in a way that they feel now comfortable as a base to go on and expand their activities and their viewpoints. I also think that, so I have a 22-year-old daughter, right? You mentioned 21st century young adults. I think that counts. 22 is definitely a young adult. And, not entirely in jest, she sometimes asks her mother and me why we screwed up the planet so much. And there is some validity in that criticism. We have just watched climate change happen. I mean, it's a little hard to blame any 2 people out of the many billions personally. I don't accept total responsibility individually for global climate change, but is clearly something that as civilization, as societies, we've been ignoring. The concentration of wealth we have been ignoring, and this leads to societal instabilities. So I'd like to believe that, once these individuals you allude to as a class have earned some money and feel stable in their jobs, they're going to be diligent in looking at their communities and their societies and trying to improve them and, improve them globally.
Professor, you are conducting an online lecture series on statistical molecular thermodynamics. How do you see the importance of distance learning?
That's such an interesting question. So that course you mentioned, Statistical Molecular Thermodynamics, I developed that as a MOOC. MOOC was massive open online course, and maybe, I guess it's almost been 10 years probably since that word first appeared, MOOC. And at the time it was thought these would change the world. Brick and mortar colleges and universities would disappear and everyone would get their education online. That has not proved to be the case. And I never thought it would prove to be the case. I actually did it because I had been put in charge the year I did it of working with the provost here at the University of Minnesota on e-learning initiatives across the university. And that could be anything. E-learning just meant using technology, essentially. But we had this opportunity to partner with a company called Coursera, which is one of the main providers of MOOCs. And they said, here's your chance. We will work with you if you give us 5. You have to develop 5 MOOCs. And I figured the only way that I was going to get colleagues to agree to undertake the work, because we only had like 2 months to do it, was I'd have to volunteer to do one myself. And so I did. And that's what came out of it. And I have to say, it was a wonderful experience, in part because I learned a lot about teaching online that I didn't know. I had taught in classrooms for years, but you need different skills to teach effectively through a digital medium. And really you need a team, frankly. You need a production team. And I got to work with a great production team. And since then, that course has basically just been running on Coursera ever since. In fact, I drop by about once every day, or maybe once every 2 days, and I look in the forums to see if there are any questions. And if there are, and I have time, I try to answer them. But otherwise, it has now, I think it's up to 70,000 people who've come through and at least looked at some of the content. And it's very clear that people go to MOOCs not necessarily to finish the course. Sometimes they just want to browse and learn a few things. Some 700 or so have actually finished and gotten a certificate associated with it. And so it's been rewarding in that respect to know that it's created this resource out there that people are using. But I do think it's a bit, it's not quite the same as face-to-face instruction and the opportunity in real time to respond to questions, to move the teaching in a direction that addresses the needs of the students who are in the room at the time. It's almost more like when people used to tell me, oh, MOOCs, they're going to change the world, they're going to get rid of universities and colleges, to which my response was, yeah, I remember when libraries did that. Because, you can go get a book from the library. You want to study from a book, go ahead. Now we got video to go along with our books, if you will. And it's really good video. It's well shot video, but still, it's not the sort of interactive, synergistic I'm using interaction again. But anyway, it's that connection between the individuals that forms the basis of a really good educational process. So I think they're tremendous tools, they're great resources. They can reach portions of the developing world that a lot of that content might not otherwise get to. So I've been particularly delighted when people have written me from, developing nations in Africa, in Asia, to say, I took that Coursera MOOC and it's so wonderful because I had no other resource locally that I could do that. And now I've got this certificate and it's going to help me, teach at my local institution. That's some of the best feedback for me. I've really loved that.
Today, due to COVID-19, the whole world is shut down. It has also affected the scientific research. A lot of research has been postponed due to this pandemic situation. Professor, do researchers have opportunities in this critical time? If they have, how should they grab those opportunities?
Yeah, well, so I definitely have a lot of expertise in what the pandemic has done to research. That's been my job for the last 6 months or so. As we at Minnesota, first we basically hibernated all of our research labs, sent people home because we didn't know what the scope of the pandemic would look like. And then we had to figure out how to reopen them and reopen them safely. And we are back almost to our full research capacity with all the appropriate safeguards you'd expect. And we have not had transmission of the disease amongst our researchers. So I think we're doing well in that respect. And so I think it's possible to carry out research in the pandemic. You know, face coverings are important, physical distancing is important, appropriate, hygiene is important, all the things that, epidemiologists knew 200 years ago were important to fight pandemic situations. So I guess what I would say is that when you ask the question, are there, opportunities? Clearly, there is now a field of research, which is what do you do about coronavirus, and how do you, perhaps develop a vaccine? How do you treat people who are ill? How do you create certain kinds of engineering solutions that reduce droplet transmission in a medical environment, et cetera? So all of those are, there was obviously a worldwide pivot of experts in those areas to work on those topics. And many governments have put a lot of money behind trying to drive that research. I think, of course, you have to be ready to do that. It's not that there's just this new field opening and people are going to study for a while and become adept at it. But virologists work with viruses. Now they're focused on SARS-CoV-2 as opposed to whatever might have been their interest before. And if we knock it back successfully, they will pivot their interest back to what they were interested in previously. So I guess I'd say it's sort of it's a short-term refocusing for many people. That's the opportunity. But I don't, as I say, I don't know that there's going to be a brand new field that people should think about as a career choice only because of the pandemic.
In your opinion, what will be the major chemistry areas that will govern the future world?
We talked about chemistry being the central science at the very beginning, and I mentioned sort of length scales and time scales. And so I think that when you think about where chemistry is having a significant impact nowadays, it's at the edges of its ability to address those scales. So we have become much better at manipulating matter in macroscopic materials, for example. So, designing those materials with specific morphologies, with specific local structures. So I'm really excited about designed materials, if you will, smart materials. I think, that obviously is not just chemistry. Increasingly, it's hard to define the boundaries of chemistry, but in any case, I would say it's sort of, chemistry, materials, science, chemical engineering. There's certainly some physics in there. If you look at things like spintronics and trying to have, ultra small scale digital information storage, I think these are terrifically interesting areas. We also obviously already talked about energy and sustainability. And so finding, solutions that are chemically sustainable using natural resources and the sun as an energy source, that's an area that is not going to go away. I'm very excited about that as well. And then finally, there's biology. This is not my own personal area of expertise very much. I've dabbled in a few things there, but our ability to understand the complexity of organisms and how molecular level processes can lead to systems level biology has also grown tremendously. And I think continuing to explore those connections is going to be a key area.
A scientist is a person who is studying or has expert knowledge of one or more of the natural or physical sciences. Professor, what are the qualities of a good scientist?
Gosh, what makes for a good scientist? Curiosity is a great start. Every 4-year-old is a fabulous scientist. They're so curious. They're so interested. Being able to retain that level of curiosity is just so wonderful. And then after that, probably I would speak to intellectual integrity. Scientists typically pursue things because they have some hypothesis. They believe that something may be true and they set out to test it. And sometimes the result of that test is that you were wrong. It wasn't true. And you prove the contrary of what you originally expected. And you have to be ready for that, be ready to accept it, you're ready to embrace it and figure out how you're going to use that to move on. And so I think that's a measure of integrity, just, respecting data and the scientific process and using it appropriately. You have to be pretty, what's the word I want to use? I don't want to use the word stubborn. I don't think that's a good word. I guess and I'm a little reluctant to use the word driven because sometimes that has bad connotations as well. But you have to be ready to put time, energy, and commitment into pushing back the unknown, right? Because that's really what science is about, at least at the research level. You are trying to discover new things, and that can be hard. It doesn't work the first time. It might not work the second time. You try to figure out other ways to get to the, data that you want, the conclusions that you need. And if you get easily frustrated or easily, tired, it's just hard to make progress. So being prepared to deliver the commitment and not be too disappointed by the setbacks is pretty critical to, peace of mind, I suppose, and satisfaction with the career.
Professor, what are your plans in the future? Do you continue to work on your present research area, or have you planned to change your research area towards a completely different pathway based on future trends?
Yeah, so I'll be honest and say that I have been vice president for research at Minnesota for 2 years now, and I really love my job, and it is very time consuming. So to the extent I continue to do chemistry research, it's mostly in service to my remaining students and postdoctoral research associates, right? I owe it to them to make sure they have a good research experience here and go on to their next positions well prepared in their great positions. So my research group is now relatively small. I really only have 3 people left after, once upon a time having as many as 15. And I will not continue to grow it, right? I have no intent along those lines. I did mention that I alluded to that I collaborate with my wife. So I still have the opportunity to have scientific input into projects that she's managing, and she has a monster research group and is terrifically successful. So she doesn't seek my advice that often, but when she does, I get to make a contribution. So and she's interested in a number of areas that I mentioned where, my group has made contributions like metal organic frameworks, for instance. So I see myself perhaps dabbling a little bit in that area, but I will no longer be at the forefront of those fields per se, except as a hanger-on, maybe with what Laura, is my wife's name, Laura, is doing. Nevertheless, I think I'm going to have an opportunity to really drive successful research done by others because of my role as vice president for research and providing them resources. So I'm very excited about things that we're doing in the sustainability space, in the biomanufacturing space, in the biomedical space, and that I get to help contribute the groundwork for.
Professor, this is my last question. Would you have something to share with young scientists?
Well, we've been sharing for an hour now, so if I try to think of any last pearls of wisdom that might somehow drop from my lips, I think what I would say is, be mindful that science is a way of viewing the world, right? Science is a tool to some extent that we use to assess truth, right? The scientific method, if you like, prescribes how you would go about assessing the truth of a hypothesis. You test it, you can falsify it. That's how we decide A or B, whatever A or B might be. Science is not the only means to determine truth, and philosophers, I think, would go into great depths on this sort of thing. There are other approaches to truth that humanity has employed over the years, and one can argue what what means for assessing truth is best or not. And there are some areas where, you know, maybe science does not provide the answers you need in order to make a decision, decide on a path forward. And so I think it's pretty important for scientists to be good at what they do, to, you know, exercise their science for the many, many things it's good for, and not to get frustrated that they exist in a larger society that does not necessarily always turn to science for answers to questions, but has other resources to try to answer questions as well. And, you know, science is part of that mix, and it's a really critical part for some things. You know, global climate change, science is at the heart of understanding what we need to do to fix that. But there are also questions of, you know, economics and social justice and, you know, how do these all roll together? So I think scientists need to be ready to engage. Young scientists need to be ready to engage with their, you know, peers across the full spectrum of society who, you know, may work in very non-scientific fields, maybe in faith-related traditions, for instance. And it's only through good communication across all those different areas that we're really going to succeed from a societal standpoint. So I guess that's my last piece of advice.
Thank you, Professor Cramer, for giving your valuable time. I believe that this interview gives chances to understand some unnoticed aspect of the life of a professor that motivate us to do useful things to society, not all for humanity, but for the whole life in the world. So let's wrap things up. Today we interviewed Professor Christopher Cramer from the University of Minnesota. We greatly appreciate that he was able to allocate his valuable time to this interview. Thank you for joining us today. Have a nice day.
And it was a delight to chat with you. I hope that this proves to be enjoyable to others who watch it. And thanks so much for the invitation.